If you were asked what's the general formula of a straight line, you may be able to say that it's y equals mx plus c, where the y and the x are just standing in for any of the x and y coordinates that appear on the line, m is the gradient of that line, and c is then the y-intercept, where it cuts the y-axis. But what could you say if you were asked what the general formula of a circle is? Well, that's what we have right here. Due to the fact that the circle line needs to loop back on itself, we do have a few extra components with this one, but it's just a few steps that we can work our way through. So just reading it, we have x minus a, all squared as a phrase, plus y minus b, all squared as a phrase, and that equals r squared, where in this case, the centre coordinates of this circle are a and b, these numbers here, just with the opposite sign, and the radius r, so that's the square root of whatever is after the equal sign. Once again, just like with the straight line equation, the x and the y are going to remain general terms that can then have any values substituted into them. We can use this formula, therefore, just looking at the equation to tell what the centre of a circle is and its radius. So here, looking at this example, in place of our a, we have a 3, so the x-coordinate of our centre is at 3. And instead of a b, we have a 1, so the y-coordinate is 1. And as for the radius, because 4 here is in the place of r squared, the radius, the square root of that, is 2. Yes, when you square root, you do get two possible answers, both a positive and a negative, but because you don't really say you have a negative length, it's going to whatever unit of distance in the other direction, the radius is just 2. Vice versa, if we start knowing what the centre and radius is, we can then construct the equation. Now, in terms of what goes in the x bracket, because it's minus a, and in this case our a is minus 1, minus 1 is a positive 1, so it's x plus 1 squared. And that's plus y, now the 5 is what's going to a positive number, so minus b minus 5, y minus 5 here, squared. And as for the radius, if the radius itself is 3, and we want it to equal r squared, 3 squared is 9. Yeah, so whether we're starting with the equation or starting knowing the centre and the radius, we can use one to work out the other pretty straightforwardly, so long as we're familiar with what the letters in this general equation are standing for. Now, with that principle in mind, we can then apply this to a question, also making use of some other line-based, coordinate-based methods, such as the distances between points, the gradients between points, and so forth. We'll see as we go forward. So the circle C with centre 2, 6 passes through point A, which has coordinates 5, 3. Find the equation of C and the tangent at A. So if we're not familiar, the tangent is a straight line that touches a curve without cutting through it. And the way it does this is that it shares a coordinate with the curve at that point, and it has the exact same gradient. Starting with the equation of C, though, we can already say that it's going to be x minus 2 squared plus y minus 6 squared. But we don't know what the radius is. Well, in general, when we're saying radius, we're meaning a line, a length from the centre of the circle to the edge of the circle. If this circle is passing through point A, we're saying that A is lying on the circle. It's on the edge of the circle. So to get a length from the centre to the edge, we just need to work out what the length between these two pairs of coordinates is. How to work out the distance between 2 points? It's basically Pythagoras. So we just set up a square root, and it will be the difference in the x's, so that 5 minus 2 squared, add the differences in the y's squared. Okay, because if, say, we have our point 2, 6 here, and our point 5, 3 here, the length between them is like the long edge of a right-angled triangle, where this height here is the difference in the y's, the 6 minus the 3, and the difference on the bottom is the difference in the x values between the 2 and the 5. And with Pythagoras, a squared plus b squared equals c squared, so then square root to get c. In this case, so 5 minus 2 is 3, 3 squared is 9, and then 3 minus 6 is minus 3, but minus 3 squared is then positive again, because the minus terms of minus becomes a plus. In general, if you're ever trying to put a power to a negative number, do put the negative number in brackets first, as in so put negative 3 in brackets and then square on the outside. So yep, you get a 9 again. So in general, you have a root 18, which is going to be your radius, your length. Therefore, we can say for the equation of the circle, we have x minus 2 squared plus y minus 6 squared equals, and again, if r is root 18, r squared will just be 18. The squared gets rid of the square root. Okay? So this is our equation of the circle. Now, as for the tangent at A, we need to know the gradient of the circle at point A. We already know the coordinates. We don't have to worry about working that out. But if we were just to imagine our circle as being something like this, and then again you've got your tangent at 5, 3, so that's going to be something like this. If we were to just sketch on this radius that we just worked out, this hypotenuse of the right-angled triangle here, so that's the radius and that's your tangent. If we know from our circle theorems, the tangent and the radius meet each other at a right angle. This makes them perpendicular. And what we can say about perpendicular lines is that their gradients, we use m for this, if you like, from the y equals mx plus c. So the gradient of the radius times the gradient of the tangent equals minus 1. So if we can work out the gradient of the radius, we can then plug that into this equation to get the the gradient of the tangent, and then we can fill out the rest of our y equals mx plus c. To work out the gradient of the radius, we're going to do a y2 minus y1 over x2 minus x1, the difference in the y divided by the difference in the x in this case. So we can have our 6 minus 3 over 2 minus 5. It's important here that it doesn't matter which coordinate you take as your x and y2 and which is your x and y1. But say if you put your 6 first for the y's, the 2 has to come first for the x. You have to do it y2 minus y1, x2 minus x1, not like x1 minus x2 to mix it up. Point is, here you end up with 3 divided by minus 3, which gives us a value for the gradient of the radius of minus 1. Now, if we just clear up this space a little, we can say that your minus 1 times your mt equals minus 1. Therefore, your mt is going to equal minus 1 over minus 1, which is just going to equal 1. Now that you know your gradient, you can work out the rest of your y equals mx plus c. And again, because it's a tangent is a straight line. That is the formula we're now going back to. So y equals 1x plus c, and 1 times x. You don't really have to write it subsequently if you don't want to. To get the c though, we're now going to plug in some x and y coordinates. The only x and y coordinates we can plug in are the coordinates for point A, because that's the only point that we know lies on this tangent. So your y is 3, that equals to 1 times 5 plus c. So 3 equals 5 plus c. Move the 5 over, it becomes a minus. So 3 minus 5, that equals your minus 2. That will be your c. Therefore, your equation of the tangent is going to be y equals x minus 2. Again, the including if the 1 in front is totally optional, because timesing by 1 makes no difference. If we're okay with that, let's see how you can get along with a question of your own. If we would say that circle C has centre 2, 5 and goes through the point -2, 3. So you have point P, which is at coordinates -2, 3, is on C. Now, first of all, find the equation of C. But then, once you've done that, we'll say that the point 2K lies on the tangent at P. Therefore, find the value of K. Pause the video, have a go at this for yourself, just on a piece of paper. When you're ready, just press play again and we can compare. Okay, so first of all, finding the equation of C. Well, like we did in the previous example, because we have the centre of the circle and a point on the circle, we can work out the radius of the circle by getting the distance between these 2 points. If we do this, you have the square root of 2 minus -2 squared plus 5 minus 3 squared. This comes, so 2 minus -2, minus is plus, so 4 squared is 16. And then here, 5 minus 3 is going to be 2, 2 squared is 4. So R is the square root of 20. Therefore, for the equation, we can say that it's x minus 2 squared plus y minus 5 squared equals, and root 20 squared is just 20. Now, as for finding out what k is, so we're looking first of all for the equation of the tangent. Even though the question isn't explicitly asking for it, you'll need it in order to get to the end. Following the same steps as we did before, if we can work out the gradient of the radius first, so we'll have 5 minus 3 over 2 minus -2 for our difference in y over difference in x. So 2 over 4, it equals a half. Now, if a half times the gradient of the tangent equals -1, and you want to get your gradient of your tangent on its own, because this is multiplied, the only way you can move it over the equal sign is to divide. -1 divided by a half gives us -2 as the gradient of our tangent. Knowing this, we can now create our y equals mx plus c. So y equals -2x plus c. Because we know it goes through point P, we can plug in those coordinates. So 3 equals -2, lots of -2, plus c. -2 times -2, because minus times a minus is a positive, so it's just 4. So 3 equals 4 plus c. Therefore, c is going to equal 3 minus 4, which equals -1. We have, therefore, a general equation of y equals -2x minus 1. Now that we know this equation, we can simply plug in the x coordinate that we know from this point that's also on the tangent, because if it's on the tangent, it must fit this equation. So y equals -2, lots of 2, -1, so you can k. K equals a -2 times 2 is -4, minus another 1 gives us a value of -5. If we're good with that then, how about we just look at what an actual exam question may be like. So here we're told the circle C with centre A has the equation x squared plus y squared minus 6x plus 4y minus 12 equals 0. And first of all, we're to find the coordinates of A, the coordinates of the centre. Now here already clearly, this is different to what we've already been working with, because now we have multiple terms. There's some x squareds, but also some x on its own, y squared, y on its own, it equals 0. What's happened is the brackets have been expanded, the square brackets have been times out, and everything's brought on the left. So we have to work out how to undo that in order to read off the coordinates of the centre. To do this, we're going to be doing a method called completing the square. If you're not familiar with this, this is just a way of putting a quadratic like this into a squared bracket followed by a number. So what we're going to do is, if you have let's say x squared plus bx plus c equals 0, we're going to create some squared brackets and do x plus half of this number in the middle. Then, outside of this, we're going to take away that half of the b squared, and then add the c that was there before. Now, this may seem like a lot of fractions and letters everywhere, but hopefully it'll make sense why this is the case when we apply it to this example here. So, we're going to look at the x's first. Let's just focus on the fact that we have an x squared minus a 6x. I'm not actually going to worry about the 12 of what would be the c for a second. Here, this is going to become, so x, now half of minus 6 is minus 3 squared. Then we're going to take away from that 3 squared. So we have x minus 3 squared minus 9. Now the reason for this is if we were to just expand this here, so x minus 3 squared, you'll have x times x, which will be x squared. X times minus 3 is minus 3x. Minus 3 times x is minus 3x. Then minus 3 times minus 3 is a positive 9. In the middle here, this just comes to minus 6x. So we have our x squared. We have our minus 6x. But then we have this superfluous plus 9 that we don't want. So, in order for the completed square form to give you the exact same value, we need to take away this 9, this value that we got by squaring the number on the right. If we now do a similar thing for the y's, you've got your y squared plus 4y. So if we put that in brackets, you've got y, and half of 4 will be 2, square that. Take away 2 squared, you get y plus 2 squared minus 4. For the same reason, if you expanded this, you'd get y squared plus 4y, but then some extra 4 at the end that you want to get rid of. Plugging that back over here, we can therefore say that this equation is your x minus 3 squared minus 9 plus y plus 2 squared minus 4 minus the 12 that was already there equals 0. So we've got our brackets now. Just to bring the like terms together, in that case just the whole numbers, you've got your x minus 3 squared plus y plus 2 squared, but now minus 9 minus 4 minus 12 gives us minus 25. Now here that would then equal 0, but if we just want to bring the 25 onto the other side, when you move something over the equal sign, its personal sign changes, so it will become a plus 25. So we can say just equals 25 here. To read off then, our coordinates of the centre, A is going to be 3 minus 2, because remember it's the opposite sign of whatever number is here. And then for part B, show that the radius is 5. Well, if r squared equals 25, r will equal the square root of 25, which is just going to be that 5. Lastly though, the points P, Q and R lie on C. The length of PQ is 10 and the length of PR is 3. Find the length of QR, giving your answer to 1 decimal place. Now, just reading this, it seems that they haven't told us any of where P, Q, and R are, other than if we were just to look at circle C, maybe like point Q, P is here, Q is here, and R is here. We have no immediate indication where they are. Maybe R could be a lot closer to P, or it could be a lot closer to Q. We don't know. What we do know, however, is that PQ has a length of 10 and that PR has a length of 3. With this in mind, this actually tells us where everything is by knowing the lengths. It's not something we have to measure it out accurately. If the radius here is 5, then a length of 10 must be the diameter, because the diameter is 2 times the radius. And here, you cannot have a line between 2 points on the circumference that's the length of the diameter that isn't the diameter itself. Otherwise, it would be sticking out the edge somewhere, like this, as compared to that. So if I actually just redraw this, we know that then P and Q, if the length between them is a diameter, are on opposite sides of this circle. So that length there is going to be our 10. Then let's say that your R is here, so where that will then be 3 again. This one doesn't have to be accurate. I'll explain why in a second. And that's because if we just link up RQ here, we have a triangle. Not only that, a right-angled triangle. Because if we again think back to circle theorems, if you have a triangle within a circle where all 3 corners of the triangle are touching the circumference, and one of the side lengths equals the diameter, the other corner must be 90. So, if we definitely have a right-angled triangle, and we know 2 of the sides and want the third, we can now employ Pythagoras' theorem, that your a squared plus your b squared equals your c squared. The c having to be this long side here, the a and the b being either way around. So your 3 squared plus your rq squared equals 10 squared. If we minus the 3 squared over and square root, you get this length here for arc your QR of square root 10 squared minus 3 squared. Plug that in your calculator to 1 decimal place. You get that as a length of 9.2.